Someone said the stream is not working. So can you see the stream online in YouTube? Yeah, I think it's online. Okay. So it's a worldwide object standard organization, or a forum that provides standards, and it has standards in many domains. And also in many categories. So the domains, for example, business, finance, healthcare, even academia, or let's say aerospace. The platform models or platform standards includes like modeling languages, how you map from one platform to another platform. Then you also have other categories like very specific to technologies like Corba or CISC. So in total, there is like more than 300 standards, and UML or UML modeling is one of them. So it's basically in the platform categories. And they have, of course, a website that's omg.org that provides all these standards. So UML is also part of UMG, and it started in 1997 as its first version of 1.1, and then it had 11 major revisions or releases for UML, and the latest one is 2.5.1, and that was released in December 2017. It has a big number of improvements, and if you compare even with 2.2 or 1.5, the way people use UML and the way people express diagrams in terms of syntax and language, it has lots of improvement and changes. And at this point, there is some UML models like BPMN or business language modelings languages. They are more executable, so you can execute the models itself. So in that terms also, there is lots of improvement since the earliest versions of UML and other modeling languages. So one of the very common or well-known part of UML is class diagrams. So UML is a language for modeling, but it's not what we use UML for drawing out diagrams. So you use different representation of models, and those are diagrams. So one of them is a class diagram, and of course there are many other diagrams. So can you give me some examples of diagrams that you worked already with in your life or in your work?
Sequence diagram.
Yeah, so that is also a common diagram, and there are also other more well-known like activity diagram or use case. So this is also very common, also very informal. So there is I think around 13 or 14 different diagrams, and every diagram has its own goal and way of representing information and action. And in our course project and the assignment, we will mostly focus on class diagram. But just to review what we know, I will go each of them over and just give you a brief idea. So the first, before going to each of them, so there is a classification of those 13 or 14 diagrams. So at the high level, those are structural or behavioral diagram. So structure diagram simply shows the structure of the system. So what are the elements in the system and how they are organized. But there is also behavior diagrams. So they focus more on interaction, more on how elements are connected or interact within the system during the runtime, or if we think that we are designing the runtime phenomena. So structure diagram has class diagram, let's say, or component diagram or object diagram, whereas behavior diagram you have activity diagram or use case diagram or state machine diagram. But you also have interaction diagram that shows interaction or different levels of interaction within the elements or the actors or entities. But those interaction diagrams are also can be from the perspective of time, from the perspective of messages, or or objects that are passing among the actors or entities. And then there is also sequence diagram that is also part of the interaction diagram. So the first model, that is the class diagram. So this simply represents the classes and the structure of the overall architecture, and also the design of individual classes or modules or subsystems. So it shows basically how many class you can instantiate during the runtime or during the system execution, and what will be the range of related or connected classes that will be instantiated during runtime. So it shows the corresponding relations of classes with one another, basically. Then you have object diagram. So the main difference between class diagram and object diagram is in class diagram you have relations with classes, but you also have multiplicity. So you specifically shows how many instances of those classes will be created. But in object diagram you don't have any multiplicity. You concretely shows, if you say that in our class diagram we will have 2 instances of that class, in the object diagram you will have exactly 2 instances of that class, or 3 instances, for example. So here, for example, you have an account class that might be of 3 types. So in your class diagram you can say from bank to account, it's a composition, and it has 1 to 3 relation. So one bank or one bank account might have 3 different account types, so savings, checking, and credit. So in this way you represent exactly the objects that will look like in the object diagram. And also in the class of account you might have attribute of balance, identity, and interest rate, and maybe other like credit limit or minimum balance. But in the object diagram or in the object model you will have specific values of those attributes. So you know the value of the attributes at runtime, basically, not in the class diagram but in the object diagram. So the sequence diagram that she mentioned also, so it's also a very common diagram in UML modeling. It shows actors on the top, and then for each actors the lifeline of all the actors. So it focuses mostly on lifelines and what each actor is doing in its lifeline until it's removed or dead, and also how those different actors are interacting within their lifelines, and how those messages are passing at different times of their lifeline. Then you also have communication diagram. So the main difference of between communication diagram and sequence diagram is you also use lifeline here and actors, but you focus more on the communication aspect of the diagram. So the more on the messages and what are the messages are being exchanged in this communication diagram. Then you have component diagram. So this is also a high-level representation of class diagram, because component from UML 2. So before UML 2.0 there was nothing called component in object-oriented systems, but after 2.0 there is a new concept of component, where components are basically a set of classes that are developed together and that interact with other components. So they have an interface that they can use to communicate with other components. So this component diagram shows a high-level representation of class diagrams and how those components are communicating and through which interface. Then you also have a deployment diagram. So it's nothing but the diagram of how the hardware and software are deployed and how they are communicating. So let's say you have nodes. So by nodes, we mean the hardwares or the any kind of server, and also we have artifacts. So by artifact, we mean the software modules. It can be a component, it can be a class itself, or it can be any interface. And then how those artifacts or software modules are deployed on those hardware, and so what type of hardware it is, and how those modules are communicating. So if using which technology, let's say it can be JDBC for Java, it can be REST for web, and RMI. So it shows a complete picture of the structure of how software modules are deployed and how they are communicating over different technologies or over the network. Then you also have the activity diagram. It's very simple. It shows all the activities or actions that are going on for a given scenario or context, and it also has a control logic or decisions based on which you can select actions or do some activity. You also have interaction diagram. So it's an interaction overview diagram where you also show different actions, but the main difference between interaction diagram and the activity diagram is that in the activity diagram, all the activities are very fine-grained small actions or activity, but in the interaction overview diagram, each block might represent a activity diagram itself. So there can be nested actions within the block, and then those blocks are communicating each other in terms of or in the form of activity diagram. Then you also have package diagram. This is also very simple. Everybody who develops in Java works with packages. So these are simply how different packages are connected if you have multiple packages in your system. And of course, those packages are a combination or collection of classes or interfaces. Then you also have profile diagram. So in UML 2, they also have a mechanism like you can extend your. So did you work with profile before? UML profile? It's a new concept, but it's a very useful concept. Maybe I could have an example, but I don't have an example here. So if maybe you can check the latest standard of UML from OMG. So it's a new concept that you can build a generic model or generic diagram that you can adapt like to different platform or different domains. So you can, let's say, develop basically you are developing meta model using profiles. So you can develop a profile for, let's say, a business process modeling. Let's say you develop a system for, or you designed a model for an academic environment, let's say in a university, and then you can apply the same model in a industry, let's say, because both have employees, but universities has teachers, universities has different policies, different roles. But in the industry setting, you have engineers, you have accountants, so they have different roles and responsibilities. But the same model or same entities can be applied to a different context, basically. That's the benefit of profiling. Let's say you have a class called server. So the main idea of profiling is they are defined as a stereotype. So whatever customized class you define, they are defined as stereotype, and then you can extend those stereotypes to whatever class you want to design. So those stereotypes basically implement or part of meta class. So every stereotype extend the meta class. So meta class is basically the lowest level class in the UML. You also have meta class, but usually every class in UML extend meta class. Let's say a server, it also extend a meta class called device, and a device can be any type of device. It can be a server, it can be a CPU, regular CPU, and then if you are extending the server as that is a stereotype, it can be a web server, it can be application server, it can be database server, and this is the benefit of using the profile. And people are using profile these days in the industry a lot. And then there is state machine diagram. Basically, it simply shows different states as a node of the diagram, and then how the transition occurs. So what are the action basically that are taking place, and due to which action they are changing the state. So this is an example for a bank ATM. So you are going from idle to active when you are inserting the card, and when you are done with your transaction, it goes back to idle. And sometimes if it's need the service, it goes out of service, and if it's fixed, it's again go back to idle. So state machine diagram shows states and actions that are responsible for changing those states. Then you also have timing diagram. This is not very used or not very often used in the UML modeling, but it's also a diagram that gives you or shows you how timing goals can be achieved. So it shows basically timing constraint. Let's say you have a web user or any user who is using the browser. So it gives a URL to the browser. The browser goes to DNS. The DNS server takes, like, let's say 500 milliseconds to find the server or find the page. So it resolves within this 500 milliseconds. So this is a kind of time constraint. So it goes back to the user or web browser, shows the page to user, it takes some input from the user. It goes to the server with those input and get the data. Server, so this might have also some delays. Server get the data, and using the JSP, it returns the data to the browser. So it also generates a response and takes some time. So let's say the time difference was 500 milliseconds. So they have different time constraint and time delays due to some actions and processing of data. It applies mostly to the modern web-based applications, but it can also model for regular object-oriented systems. But it has a good use of showing how different objects or entities are interacting in terms of time delay or time constraint, and minimize the overall time constraint or time requirements. Then you also have a very classical use case diagram. This is also not very used these days, but this is also good for end users because you can show in a very high level point of view how users are interacting with the system, and this is mostly done by pen and paper, and it really doesn't help developers in terms of technical contribution like class diagrams. So this was about 13 UML diagrams. Then as I mentioned before, UML is all about modeling, and it's a language. And a model captures interrelated set of information. So those information should be interrelated. That's also the important thing. And there is a slight difference between diagram and model. And I want to ask this question to you. So as I mentioned, model, so here it's mentioned that model captures an interrelated set of information about the system, and the diagram is simply one view of that information. But we talked about model, let's say UML model or UML modeling language, and then we had also talked about different diagrams: UML diagram, class diagram, use case diagram, timing diagram. So what do you think that what's the difference between model and diagram? Any idea? Or anybody from Slack? Just from the basic concept. So you know the difference between, or even in terms of English language. So you know the difference between model and diagram, right? Or even in terms of software engineering, what's the difference between model and diagram? Any idea? No? So there is two main difference. So as I mentioned just the line before, so a model is a general representation of a context or of a problem. You can model a university only once, and then you can represent that model or concept in many different ways. So you can represent, let's say, the employees as a table. You can represent employees as a class diagram, as a different entity. You can represent employees as a simply a list. You can represent employees using how different employees are connected, like whose boss and who is working with whom. So there is many different way of representing employees in the university as a diagram, but there will be always one model. So this is one difference. And another difference is that I would say it in terms of modeling concept. Like if you, so let's say we have a model for the university, Linnaeus University, and if you delete one concept or one element from the model, it will be deleted from all of its diagrams. So whatever diagrams you are drawing from that concept or from that model. But if you have a model, and let's say you have 5 representation of that model, but you delete one of the element from one of the diagrams, it will not impact the model. So you got the idea? So vice versa. So if you delete something from the model, it will be deleted from all the diagrams automatically. But if you delete something from the diagram, it will not affect or not impact the model. So this is another one important difference between model and diagram. So class diagrams describe data. So we all know that class diagrams are classes and classes are entities, but the most important fact about class diagrams are that they represent data. So even if you are modeling a bank account, it's about data. Even if you are modeling a ship, it's about data about the ship. Whatever model you element you model. And of course the essential elements of UMLs are classes, associations, attributes, operations, and generalizations. So we will talk about associations and generalizations later more. Then they have also a little bit differences in terms of UML context. But let's come to the classes first. So classes are the first class entities of UML diagrams or class diagrams, because you design everything based on classes, and they might have different levels of detail, and depending on the phase of the development. So in the very first phase of the development, you can simply have your class without anything, and then you can slowly add the details to it. So let's say the rectangle has a class name, it has nothing. Then the next phase of your iteration or design, you think about that rectangle might have an area, it can be changed, and the size. So you introduce two operations or things that you can do is to calculate the rectangle, the area of the rectangle, and you can resize or change the size of the rectangle. Then you thought, okay, rectangle can have properties or attributes, so it have height and width. So you combine them. So you combine those properties and attributes. So you come up with a more detailed and stable class definition of rectangle, which has two properties and two responsibilities. So operations are basically responsibilities or whatever this entity can do. But then you can also add more detailed in terms of how those properties and attributes will be viewed from outside world. So some of them will be private and some of them will be public to all other elements in the class diagram. And you can also define the data types and how or what types of data those responsibilities or operations will be handling and using. So a detailed operation signature can be look like this. It will have an operation name, so which will also have different or a number of parameter name and types. Usually in the UML diagram, we don't represent a parameter name in the definition. We just simply put the type, and then it might also have a return type. Like here, the get area, it might return an integer value. So we also talked about associations and multiplicity. So association is simply a line between classes, but it also shows basically how many instances of the connected class will be created while the system will be implemented or instantiated. And the symbols indicating the multiplicity are shown at each end of the association. So this is the example. So the example shows so one company can have multiple employee. So by default, static means 0 to many. If you don't put 0, then in the company there might have at least one manager and maybe many. So all those managers might have administrative assistant, maybe many also. And each company has one board of director, and each office has 0 to many employees. And then some person, so that it can be 0, it can be 3 to 8, might be involved or part of the many board of directors. So there is a transitive relations also. So did you see any transitive relation between these classes? So if I want to join multiple classes and make a more complex associations, can you make it from here? Sorry?
Office to company.
Office and
To company.
how?
No, I was thinking the first line and then the fourth.
Yeah, this is one possible. Then if employee company and company board of directors can be another possible. So one company might have multiple employee, and one company might also have, so should have one board of director. So you are also right, yeah. One company might have multiple employee and multiple employee can work for 0 or 1 office. Yeah, this is another possibility. Then about labeling the associations, there is some good rules about labeling associations that you also should also follow during your modeling. So in general, there are two types of associations. So one is simply association name, so whatever name you prefer to give, but there is also one for roles. So for example, here it doesn't have any associate, or in the previous slide it doesn't have any association names or even role names. You can modify these associations or relations using labels, and it's always good to have a verb or combination of verb and other words to name the associations, because it will show clearly the relation between those two connected elements or classes. And if you do not put any names, by default it says has, but has does not have always good meaning between two classes. So it's always good to put names as a verb, and maybe well-defined verbs. So as with the previous example, many employees works for one company, and if I connect to this one, so no, this one, it says 1-to-1, so we already know that one company has a board of directors. But if I connect with this one, it says 0 over 1 office is allocated to many employees, or many employees work for 0 over 1 companies. And for this one, as you can see, it's also verb. This is verb phrase, this is verb phrase, this is also verb phrase. So here it says one or many managers, supervisor is supervisor for many administrative assistant. So usually we place what it does or what a class does on another class. And here it doesn't say a verb, but since both of them are noun, and it simply shows what it's doing basically as a person as a part of the board directors. So it's doing as or working as a board member for multiple or many board of directors. Or in other words, many board directors might have 0, 3, or 8 board members. Then in terms of multiplicity, it's very easy to make mistakes on associations, and especially not only for naming but also for showing how many instances will be there that should be precisely created during the instantiations. But among the associations or multiplicity, there is 3 common relations, so one-to-many, many-to-many, and one-to-one. So there is an example, a one-to-one relation between person and the person information. So one person might have one address, one email, and one birth date. But sometimes these one-to-one relationships can be combined, because if you are creating in this way 2 separate classes with one-to-one relations with unique attributes, that means you are wasting your memory and also development effort and time. But if you create one single class, let's say person, name, address, email, and birth date as attributes, it will save your memory and development effort and time as well. Because when you create an instance of class, it of course takes some memory in terms of what data it represents. But So this is one-to-one cases, but there can be other complex case like one-to-many and many-to-one. Let's say one person or one passenger can book many flights or can have many bookings, and then one flight can also have many bookings. So many bookings can be done in one flight. So this is one-to-many and many-to-one example. But what are the other examples or other multiplicities that we can consider here? Any ideas? So if you just consider these three cases of multiplicity, so what are the cases that we can introduce? Can we say that many passenger can have one booking? It doesn't usually happen, right? And also we can say that one flight can have one booking, but it doesn't make any sense. Usually one flight doesn't fly with one passenger. And also we cannot say that many flights has one booking. It's also not usual, right? So this kind of associations that doesn't make sense or that are not realistic should be well taken care of during your design and modeling. That I wanted to say with this slide. Then there is another concept. So do you have idea of what is association class, or we have the idea of classes, but what is association class? Or it's also a very useful idea or concept to use in UML modeling, because in some cases, in most of the cases, we can say that students is registered. So many student is registered in many courses. We can say that, but we do not see here, like if we have 10 students and if we have 10 courses, from this simple model, we cannot say which students are registered in which courses. That's the problem. So the problem to this solution is to create a association class that will have a third class basically in between them, and it will have 10 students here in this class, it will have 10 courses here, but in the third class it will contain the information that basically will map the students to class or student to course, let's say in terms of grades or in terms of attendance or in terms of registration. So now if we have a student and we have a course, we might have a separate class for registration, for example. So we know that using this class we know which class, which students are registered to which course. So this class can have different information in terms of registration, in terms of results, in terms of assignments or whatever, and it will map basically between these two classes. And now at runtime we can clearly see which students are registered to which course and which students got how much grade or what is the result for each student for each course. So this association class is very also useful and in the real world problems, because in the real world objects are not very simple. It can be very complex, but they can be represented also in this way. So now you can see we can transform this association class from from one many-to-many relationships to two relationships, that is one-to-many and another one is many-to-one. So now we can create a number of instances of this class. So if we have 10 students, we will create 10 instances of this model, and each students will have multiple grades, and those multiple grade also linked with one course. Let's say. So basically, one student can have multiple grades, and one course also have multiple grades, because one course is taken by multiple students, and one students also have multiple course. You got the idea how this association class works? So this is the use of association classes. And association classes should be always named using a noun that reflect the meaning of association. So you cannot call it as a verb, because before we talked about association labeling, but we told that we should rename this as a verb or verb phrase. But if we are considering creating association class by removing association relation, we should name it as a noun, so that it relates what it represents, but not what it's doing. And there is a tips. So check for many-to-many relation or associations if you can replace with this association class. So usually many-to-many relationships are super flexible, but are very vague. So they do not. It's hard to imagine or represent them in the real life problem scenarios. So it's always easy to break them down to a new relationship sets like one-to-many and many-to-one. And then there is also reflective associations, and this is also a common use of association relation. So a class can be associated to itself. Let's say for you have 10 courses in this figure. So a class can be prerequisite of another class, course, and then a course can be successor of another course. And also a class can be mutually exclusive with another class or course. So let's say you have 10 courses and 10 of those are mutually exclusive. So if you do one of that course, you don't need to do other if you want to fulfill the requirement of prerequisite. And that's why this type of relationships are known as asymmetric relationships, because for each end of the association you know exactly what it represents. So many successor course has many prerequisite course, or many prerequisite course has many successor course. If you have multiple course, here you know the name of each end, or you can provide a name for each end of the relation. But in the mutually exclusive case, you cannot provide a common or name for the both end. So that's why it's called symmetric associations. And this is also not very used in practice. In practice, you should always name the both end of your associations where it's reflective. And then there is another tip. So label an asymmetric reflection association using role names instead of an association name. So again, in terms of reflective associations, you should use the role names. So what role is playing, rather than using a noun. So in the previous example, we said you should use noun to name association or association classes. But here we are saying that you should use role names or verbs to represent reflexive associations. And there is another important thing about associations. Those are directionality. So by default, associations are always bidirectional unless you put any arrows. But there can be also directional association. So let's say this one, This is unidirectional association, and it says that each day has in your calendar, let's say, each day you might have multiple nodes, but you can also say that if you change the direction, so will it make any sense? Like multiple node might have one day. So that's why this direction is important for association. And when the instance will be created, it will assign, or it will map or link nodes, multiple nodes to one day, basically. And then there is another tips or note. So making associations bidirectional or unidirectional can improve efficiency. So if you have a link or direction from day to node, you can clearly see that one day can have multiple nodes. It will improve efficiency and understandability, but at the same time it will reduce the complexity, but it will limit the flexibility. Limit the flexibility in terms of the sense that I mentioned, that so now if you remove if you make it bidirectional, you can have multiple nodes to one day, or you can have let's say multiple nodes to multiple day, but now you have only one day to one day with multiple nodes. So it's basically reducing how much variations you can have in your UML model. So you can go only in one direction. Then there is also a common concept of generalization. It's basically the hierarchical relationships between classes. The classes at the top we call superclass or base class, and then the classes at the bottom we call subclass or derived class. So savings account, checking account, and mortgage account are type of classes. So when you derive a class, let's say savings account, you get all the properties of the account class, and you can have your own properties. So let's say checking account does not have a interest rate, but savings account can have an interest rate, but both of them can have balances. And then also mortgage account, you can also have balance, you can have interest rate, you can also have one extra feature or attributes or properties called monthly payment, for example. So you can instantiate the account class, and you can add more attributes or features to derive the savings account or checking account or mortgage account. So this hierarchy with one or more generalizations, it calls inheritance hierarchy and or generalization hierarchy. So it's an idea of inheritance, basically. I'm sure you know about inheritance and polymorphism in Java. But what is the difference between object diagrams and class diagrams? So any idea what's the difference between object and class diagrams? I think I already mentioned in the beginning. So one of the differences is object diagrams doesn't have multiplicity. It doesn't have also the directions of associations, because all those are represented in the class diagrams, and when you create the instances of the system, you basically translate them how it will look like concretely. So that's the main difference between them. So here is an example. So we can say multiple employee can work for one company, and one company will have one board of directors. So this was the class diagram, and the object diagram will be look like this. So if you see here, so we said one company we will have one board of directors. So the company has one instance exactly, and the board of directors has one instance exactly. Then we also said one company or multiple employee works for one company, and we don't know how many, so we can create as many as we want. So we have 3 employees, and they are all working for this company. So this is one very simple example of translation between class diagrams and object diagrams. And here you don't have directions, but you can also add directions, and if you have directions, it might reflect in the object diagrams and change the object diagrams at runtime. So that's the reason, since you are getting this image at runtime and after you instantiate the class diagrams, that's why it's called sometimes instance diagrams. So it shows the instances of the classes that you created. There is also a difference between associations and generalizations. So associations describe relationships that will exist between instances at runtime. So if I could show the example of on the board, it would be better. So in generalization, you have multiple levels of classes, right? So you have accounts, and then you have checking accounts. Then you might have different types of checking accounts. So they have different levels or hierarchy. But in associations, you don't have labels. You might have like discrete or organized branches. So the main difference between these two is when you instantiate the associations or association classes, you have multiple instances at runtime of multiple classes. But when you instantiate a class in generalization relation, you instantiate only one class. So if you are creating, let's say from this example, this is a generalization example, right? So if you create instances of a checking account, it will not create instance of account or savings account or mortgage account. It will create only instance of a checking account. But this is for the generalization. But here, in case of association, so if you create an instance of a company, let's say, you must create an instance for employee, because you need to relate between a company and employee. The company cannot stand alone here in this figure. So this is the one of the major differences between association and generalization. So here you are creating the instances of the company. At the same time, you have to create the instances of the employees. But in other case of generalization, you don't need to create objects of mortgage account or other accounts if you are creating instance of only checking account. And object diagram can never contain a generalization. So this is also a good useful information. So we saw generalization in the previous figure here. So this was a generalization or inheritance example. But we also have examples of class diagrams here. We don't have generalization here. We could have, because this employee, for example, could be working under somebody. So it could be somebody could be his boss. So we could have another employee or another role or another class that could be generalized with this employee. But when we are creating the instance, it will not be in the object model. So what I wanted to say, that in the object model there is no hierarchy or there is no layer. So those are concrete objects. And to show an object diagram, so this I already mentioned. To show an object diagram by association, you show in all the instances or instances of both classes within the relation. But for the generalization, you don't show all the classes or both the classes. You show only one classes. It's for those accounting example. So you create only one class of example, one class of account. Then there is also a aggregation. So we are talking about association. So the relationship between classes and among the classes. There is another types of relationships between the classes, that is aggregation. So as aggregations are special relationship between classes that represents part-whole relationships, and the whole part is we called aggregate or assembly, and usually it is represented by a diamond, and in most of the cases aggregations are one-to-many. So here is some examples. So let's say, so this is the aggregation relationships, the white diamond. So one vehicle might have multiple vehicle parts. So it has doors, it has engines, it has mirrors, other stuff. One country might have multiple region, and one building might have multiple room. But then there is another type of relationships. I will come back after. It's called composition. But before going to composition, let me introduce interfaces. So interfaces are visible behavior of the set of objects. So I am sure you know already about interfaces. Some of the guy from Slack asked, what kinds of diagrams are these UML basics for? I did not get the question. Maybe I can answer him after. So interfaces are basically it represents what it does. So it's the base class in other words. So you can extend the interface, and you can implement the methods in the interface whatever way you want. And in Java we use implement keyword, right, to implement interfaces. So in the UML model, usually we represent interfaces by this stereotype. So this is another example of stereotype, and this stereotype stereotype called interface basically extend a UML meta class, and then from this stereotype you can implement whatever way you want for this cashier interface. So this is one of the example of profiling basically. So you can implement this cashier class either as an employee or as a ATM, or you can other form of classes. In the old form of UML, it was in the interface was represented using this small round, but now it is more represented as a stereotype profile called interface. So this brackets, this curly brackets known as guillemets or guillemot, is a French word, and but what's the difference between generalization and interface? So we also talked about generalization with that account figure, like you have account and then you have three different types of account: checking account, savings account, and mortgage account. So you can extend the account class and create three different accounts. But we also talked about cashier, let's say here, that you can implement in two different ways. So there is a similarity between interface and generalization, but what is the difference between them? Any idea? so you used interface, right, in Java a lot, but there is a slight difference between them. So the idea is that in the generalization concept, we call these relationships is easy relationships. So in the if you remember the account example, so a savings account is a account, a checking account is a account, so it's more close to that relationships, or the relationship is more stronger. But interfaces define these relationships as a can be seen as. So you see that types of, so it's like the brother-sister relationships between classes, and this is like cousins. So this is more strong relationships. So the generalization is more stronger than the interface. So you can also extend the interface, or you can implement interface. Basically, there is another slight difference between these two. So for the generalization, you use the keyword extend, right? But for the interface, you use the keyword called implement. So this is also another difference in terms of implementation. And generalization is more stronger relationships, or more strict than interface, because in the interface you cannot modify the content of the interface. So there is another relationships between classes. So we talked about aggregation, but then there is also composition, and composition is basically more strong aggregation. And then there is a slight difference between composition and aggregation, and it's also already there. So the main difference is that for the aggregation, so you remember the diamond for the aggregation, it was not filled, white, and the composition, it's black, so it's black diamond. So the difference between these two is when you, for the aggregation, when you destroy this part, let's say there was an example with car, right? So in the car example, if you destroy the car, or if you break the car in different parts, the parts will be there still. And if you remove a part from the car, let's say you remove one of the door, the vehicle will be still there, so you can still drive the car. And it will be it's the same for the country. So if you remove one region, or if it's one of the region is independent, the country is still there, because the whole country did not break apart. But if you also let's say this is Soviet Union, so you break the country and the regions are still there, so those regions became independent country. So this is the case of the aggregation, but this is not the case for the composition. Let's say in this example, if you break a building or destroy building, all the rooms of the building will be destroyed. So this relationship will not hold anymore. And also from the building, if you destroy all the rooms, the building will no more be there. So there is this difference between composition and aggregation. And a one-to-one composition often corresponds to a complex attribute. So you might have an employee that has an address, but address is not address, it has many other information. So what you can do, you can break this complex class into a composition relation. Like one employee might have one address, and that address might have multiple information like street, city, country, and postal code. So in this way, composition relation can be useful by breaking multiple or complex classes into simple set of classes. So describing the UML, after this slide we will have a break. So we can remember in the previous lectures we talked about how we can paraphrase the models. So we can describe the models in different notations or languages, and it's also good for requirements if you paraphrase the models. So this is one of them. So you can describe, or you should describe, your UML in different ways depending on the target audience. You should describe your UML model in text, let's say descriptive text or diagrams, and you can also explain your UML in terms of design rationale, not by what class it has or what relationships it has between classes, but you should more explain why. So it will give you also the more insights about the model. But you can also describe your UML models using nodes. So in the more recent versions of the UML, it has a feature called nodes. So you can simply tag it to any class or any relations, and say anything about you want about the class or relation. But there is also another technique, that is you could check and you could express the meaning of relationships or the condition or state of the relationships between classes and even about the class. So have you used OCL, or object constraint language, before? No, this is also a very useful there is a question from the Slack. When modeling, let's say, Java classes using class diagram UML modeling, when will bidirectional associations will be necessary? In earlier courses we have been taught to use only unidirectional associations. So you got the question from the Slack? Sorry, yeah? You got the question from the Slack? There is a question from the Slack. So Niklas Eriksson asked, when modeling, let's say Java classes using class diagram UML modeling, when will bidirectional association be necessary? Because in earlier courses they were taught only use unidirectional associations. So when bidirectional associations will be useful or necessary, he is asking. And there was another question, any example of how we implement composition in Java? So any example, do you have any idea? Basically, I have a small introduction to it, but one of the way to implement composition is to use different design patterns. You know design patterns, right? So they have good use of these associations, aggregation and composition, and they have very well-defined rationale why we should use those composition. So since this was part about requirements engineering or modeling requirements, I did not introduce or talked about anything about patterns or anti-patterns. Yeah, maybe this can be a good source of information why we should, or how we can implement composition. So yeah, so this OCL, object constraint language, so you haven't used it before in your any of your. So this is a good way basically to not only to annotate your UML model, but also to check if your UML model is correct, or the whatever you are designing, if it does make any sense in terms of common sense and in terms of technicality, in terms of design decisions. So I will show a very simple example of this OCL after the break, but this is one of the example. That's one of the book from one of the books. So you can annotate, you can add note to the classes, and then for each of the classes you can add constraint, and those are called object constraint language, or OCL, because you impose or you check the constraint on each object. But you can also check the constraint on the relations, but those are more advanced. So in this way, basically you put your conditions or logics to check if those classes satisfy something. So have you used Papyrus for modeling? So what tool you use for modeling, for UML modeling? Sorry? Okay, you don't use Eclipse?
Yeah, it's for stuff.
Okay. So UML Eclipse Papyrus is, I would say, one of the most advanced, it's also free, most advanced tool for UML modeling, where you can model I think all of them, like 13 or 14 different diagrams. And you can also not only model, you can instantiate model, you can generate code from the model, and you can also validate your model using OCL and other techniques. So I think I will have a break, and let's say 5 minutes. have computers, right? Or with you have laptops. If you want to try this tool, but it will take some time to install it and download it. So Papyrus is very strongly used in the industry and also designers for UML modeling, because it's particularly developed environment for Eclipse to develop models. So you really cannot do coding and development and testing here. It's more about developing. So maybe you and in the assignment there will be some modeling task. So you can use whatever tool you want, but if you are doing, I mean, if there is any task for OCL or checking your models, it's good to use this this tool, Papyrus. So I will show a example of Papyrus and also how to use SOCL to check if your model is well created, and if you did a good design. But it's only a small example with one class. So let's say we have a class called person, who has a attribute called name, and it's a string type attribute, and it has only one value. And a person, so we can create the instance of this class in many different ways, because as you can see, it has reflective associations. So if we want to create an instance of this class, and we want to say that so one of the relationships is partner. So one person can have 0 to 1 partner, let's say. Another relationships is the children. So one person can have 0 or many children. Then another reflexive relationships is parents. So one person can have 0 to 2 parents. So if we want to instantiate this class, we might have a person-to-person relationships that are between partners. We might have a person-to-person relationships that are between children and parents. So at that time, that person will be parent of these children. And we might have a person-to-person relationships that are basically partners, because those are parents of these children. It's a triple reflective relationships, but it's a simple class with one example. So one of the first thing to check is this in this class, as we mentioned, the name of the class or the person should be a string. So we can check using regular expression that the name can or only have alphabetic characters. How we can do that? Maybe the answers are in the slides, but I can also show it on the screen how we can do that. So let's say so I have this model. So this is, you see, mostly look like Eclipse, but it does not have any Java project or anything. It's all about modeling project. So it's very specialized for modeling. So I have this class, and the first thing is, let's remove the take the class. So I have this class, and I want to check that where is the I want to check that the name of this class is only alphabetic. So what I can do, there is so in Papyrus, you see there is nodes and there are edges or relations. So there are all the nodes, many kind of nodes that you can have, all types of UML elements, and then there is all types of edges or relations you can have in the UML model. So let's say we want to have a constraint. So we drag it here, and this constraint is applicable to this class. So we simply choose this class, and if we choose this, it will basically, and if we go to the constraint, you see in the context location it automatically chose the person, but I can change it from here. Like I can apply this checking to any of the attribute, but right now I will apply it. So this is the name of the class, so this is also the name of the context where we are applying, but for this check we can apply to any of the attribute, but now we will apply only on the name attribute. So how we can do that? So an OCL constraint which always or should be always evaluate to true. So by default it puts true, but we can modify this condition, and that will be checked runtime. So to modify that, just so you can either press F2 or you can modify it from the specification tab here. So you can go to edit, you can so this one is already added, so you don't need to add the language. So basically you can add also other language, but I chose OCL, and if you edit the condition, so it's also kind of programming language. So we are checking if the name of the class is alphabetic, right? So for that one, if we use the keyword self, it will always is the keyword like this in Java, so it will point to that object or the person, and we can say that self.name. So it's basically the name of this class or this of this person. Then we can say we can use a regular expression. We can say, let's say, matches, and then it should be A to Z, and from A to capital Z, and then it should work third bracket. And then everything. So it didn't update, and you can also give the name. So let's say okay, let's exit the slideshow, and you can give any name. Let's say we call it check only alphabet, it did not update, so sometimes it does not reflect the changes, so you just close. Okay, it still did not update, so it's better to write it here so that that change directly happens. Self name dot matches, then then third bracket A to Z, then capital A to capital Z, and then you have any other yeah. So now it's there, and also the condition is here. So now when you will create the instance of this object or this class, it will automatically check or run this OCL constraint, and it will check that if the name is between capital small a to z and capital A to Z. So if it doesn't have any of those, or if it does have other characters in the name, it will fail, or it will give you an error basically at runtime. So the format is that, as you can see, the OCL starts with this OCL word, so within the curly braces, and then the expression, and this expression is basically evaluated, and on top you have the OCL rule name or constraint name. So this is one example of the constraint. Let's minimize it. Then we have another example that says check that the partner relationship does not have the same person as both its source and target. So the partner of a person should not be itself, it should be different person. So it says self dot partner not equals to self. So if we are again applying this rule to the class, so we add a constraint to this class, and if we want to edit by F2, we can check, we can say that self or this class, and it has a relationship called partner, right? So this partner will come no Swedish keyboard. Yeah. So not equals to self partner. So it will also check that the partner of this object is not itself. So that means that partner should not be the same person and see, I write it here, but it says there is an error, but actually there is not. So for this one, you just need to reload the model. The error is still there. It should not be there. Where is the clean project? is it still there? Sometimes the error sign does not go off due to various reasons. Okay, next let us try another one, and it says, this is an interesting one. So it says each child should have maximum of 2 parents. So how you will do that? Let's maybe describe. So basically there is 2 operators that you can see. One is this dot, and then there is another arrow. So this dot operators is the single element operator. So when you call something self dot, that means it get the self object or this object, let's say the person object, and dot children, that means it will get all the children that has this person and that this person has. But then there is another operator, that is collection reference. So this dot is individual reference, so it will get all the properties of this self, and then there is this arrow, it doesn't select, it will get all the properties of a collection, not a single object. So once we get the children of this object, that means we might have many children, and for all the children, so with this self dot children we will get number of multiple children. So now it will pass this number of children to the next phase, and then for all the children we got from our left, for each child this bar is means in OCL means check that. So for all the children that we got from here, for all child, check that child dot parents. So the parents of each child, so we might get either 1, 0 or 2, and now maybe I could draw it on the board. Let's go to the board. It will be easier to understand. So we are telling that so this is one child, and each child has one parent, at least 2 parent. This is another class, and these parents are basically partners. So these are partners. So with this command, I cannot see myself. I need glasses. Yeah. So with this command, for the first class, it will get first the children's. So let's say we have 1 children. So this is the object. This is our target object. And for this class, we get the children. So we got 1 children, this one. And for all children, check that parents. So these are the parents, 1 parent and another parent. The size of this set, so it will return a set, is less than 2 and greater than or equals to 0. So here we have 1 parent and we have another parent for this child. So total we have 2. Basically it should be or, not it should be and. So we got 2 parents for this child, that means the first condition, so for this child, first condition did not hold, but the second condition hold. So basically that should be OR. So for each child it will return all the parents, and it will check how many parents it has. This is how it's done in OCL. So it has three different operators. So the first operator is dot. So this is important to know instead of how it's working. The second operator is this arrow, and the third operator is this bar. So this dot operator represents one single reference. So it will refer to only one object. So it will get all the properties of of this object. That's why it got the children of this person. Then it has this object. So if it has multiple childrens, it will take it as a set and pass it to the next phase. And then for each child, it's by this bar, it's basically doing the checking. If the number of parents of that child is less than 2 or greater than or equals to 0.
Do you need to change the camera?
Did not come back. Yeah, I think it's good now. But camera is still there. And then another check. Yeah, I think now it's good. So another check can be a person cannot be parents of his own. So how it can be written? Okay, I have the solutions here, so I will not draw in the Eclipse because it's the same. Basically, you for each of the constraint, you drag the constraint here and write the conditions. So it will be the same for all the constraint. So I will show you the examples and the answers. So how it is done? So a person cannot be parents of his own. So let's say we have this person, and self.parents means if we have multiple parents, we are saying that each person have 0 to 2 parents. So by doing self.parents, it will get all the parents. It can be 1, 0, or 2. And then there is a closure. So this is a special function of OCL. What it will do, it will merge two sets. So how it will do? So function, then parent. So for self.parents, that means it got all the parents. And for each parent, it will check if the parent of the parent is not the person itself. So basically, it will exclude the self or this object. If this is the case, that means it's true. So a person cannot be parents of its own. So first, it's getting the parents by these relationships, and then after finding the parent of this person, he is also checking if the parent of that person, but basically of that person and this person is the same. It's a little bit hard to visualize with one diagram. I should have an object diagram also. So basically it will check if the parent of this person exclude the parent of the person of it's hard to explain also. In other words, it will basically take all the parents of this person and check if those person exclude itself or the object itself. If it doesn't happen, that means we don't have we don't have this wrong relationships that a person cannot be parents of his own. And then there is another check that can be imposed requirements that two parents of the child are partners. So it's known that if we have two child, so we said that we might have multiple childs. If a child has two parents, that means they are partners. And for OCL, it can also check that these relationships hold in the object model. So so the goal is to find if two parents of a child are partners or not. So how it's done? So this is another command in OCL. So let expression or let command. So as you can see, it has 3 different colors. So let expression, then this is the variable. So this is called let variable, and this is the assignment operator. So the value of this blue statement or expression will be assigned to this value, and then this value will be assigned used in the next phase of the expression. So this let expression has a format, a very fixed format. So let this expression, then there is a term called in. So whatever value this expression return in this variable will be used in the later phase. So this self and partner is used here. So how it works, that how the checking is done that two parents of a child is partner. So let's say self, so one person, and OCL as set. So this object will be taken as a set of objects. So we have only one person basically, since we have only one class, and then it will be transferred to the next phase. So this, as I mentioned before, this arrow sign, it transfer a set of objects to the following phases. So including sets of partners. So it will join this. It will join this object to the partner object. So this person might have partner, right? So then we have one person and another person as a partner. So now we got two partner, and now we have to. So this two partner. So the person and the partner of this person will be assigned to this variable. So here we have the partner and the person and the partner of the person, and this set will be used here. How? So it will check for each children. So for all the children, check that the whatever we got from there, the person and the partner of the person, they also have children, right? So it's also a little bit long. Maybe I could also draw the figure. So without drawing the figure, it's hard to visualize. So basically, it will get for each person, it will get the partner, and for each partner, it will get the children's. So it will have one children. If we have a children with two parents, and those parents are partners, so for each of the partner, the children that we'll got at the end, it will be basically the same children. That's the goal of this expression. But without drawing, it's hard to visualize. Again, so there is a new expression or mechanism of writing constraints is this let variable. So let expression. Then this is a variable that will be used all along this expression. So that's why it's called let variable of the let expression. This assignment operator. So whatever we have statements here, whatever value we get from this statement will be assigned to this variable, and this variable will be used whatever expression we have after this in keyword. So this is the keyword in OCL, in, let, and they also have self, like in Java is this. So the basically in keyword you have left part and the right part. So whatever values we have in the left part, so let's say this values or this variable, it will be used in the right part of in statement. So it is being used here. Yeah, I know, without the object diagram, because this is the class diagram, basically this constraint, all these 5 constraints will be checked against the object diagram. So it's without the object diagram, it's hard to visualize the impact of those constraints. So these are the basic operators of OCL. So you can reference to role names, you can reference to association names, you can check constraint on any of those attributes, classes, associations, and even the operations of the classes. Then you can have 2 different logical values like true or false. You can have multiple logical operators like and, or, equals, less than, greater than, and not equal. Usually string values are written as within the single quote as string. There are two different numerical values, integer and real numbers, and also you can perform mathematical operations like addition, multiplication, subtraction, and division. So some more about OCL. So OCL is also a part of the object management group, or OMG standard. So they also have a well-defined standard and how to use OCL. And the latest version is OCL 2.4. From this URL you can find this standard. And OCL was developed by the IBM. Not very recently, not very old, and it's a pure specification language. It means it doesn't have any side effect, or it doesn't change anything in the UML models. It's also a not programming language, so it does not have any logic or control flow. It's just the expression that we will check. So that's why there was no control flow within the expression. But there was simple check, like if size of sets is greater than or less than some value. OCL is a typed language, so it should be always compare integer with integer and string with string. So you cannot check a string and integer values. And the evaluation of OCL expression is instantaneous. So you can, whatever expression you are writing in your model, it will be checked right that moment. And if you change your model and you already wrote your expression, it will be also evaluated right after you change your model. And also you can define your OCL constraint on UML profiles. So here I showed an example of defining OCL constraint on UML models, but you can do it also on profiles. That is also useful. So I will finish the lecture in defining some types of models. So there are 3 types of model basically. The exploratory domain models is basically for the end users who don't have any technical knowledge or technical understanding of model specifications, and usually requirements engineer or people who are part of requirements elicitation team, they draw this kind of models to understand the domain in the first place. And then there is also system domain model. These are mostly the UML models and use case models and other models where you put your class and what are the responsibilities it could have and what are the attributes it can have. And then you have the final system model. So it's basically the system requirements specification. So on top of those system domain model, you add more technical information in terms of user interface, in terms of the architecture, how it will be used, and also in terms of utility classes. So you make it more technical and also more suitable for the developers. So models, those three models can have different types of information, and they can represent different kinds of information. And for example, the exploratory model, the system domain model, that's a UML model and other models, and the system model, they all have elements that represent things in the domain. So those are very high level concepts or elements from the domain, from any domain basically. But then the exploratory domain model, that is the very high level model of that was built for just for understanding of the domain. It does not have the things that will be implemented. So the things that will be implemented are only in the system domain model, like in the class diagram, or system model. So that is the more technical or system requirements specification model document or requirements document. Then the things that will be also implemented, but that will be also used for deploying and building the complete system, will not be part of the system domain model and exploratory domain model. They will be only part of the system model, because it will be a complete specification of how requirements will be implemented, not only but also how they will be deployed and which system. Let's say this system model will have the deployment diagram, for example. So it will have detailed information on the deployment. There is a suggested sequence of activities for modeling. So whatever language you use, whatever tool you use, there is always this sequence of steps that you should always follow. So you should always start with defining a candidate classes. So very high level classes, what are elements or the main elements that you can think of for a given problem. Then you also go for the defining associations and abbreviations, attributes. So for those classes that you defined, what could be the relations between those classes, and what could be the attributes for those classes. Once you define the association and attributes, you now go for the generalization. So if you can generalize your classes, so if you can have any hierarchy of between your classes, you have to check that. And once you have the association and generalization and attributes, now it's time to define the responsibilities or the operations of the classes. So if you define the responsibilities after step 2, you will already miss, and it will be already more complex to define associations and generalizations, because it will be already too much information in the class. So that's why you always need to identify the attributes and the associations before identifying generalizations and responsibilities, because responsibilities are the ultimate goal for each class. And based on the responsibilities, decide what are the methods or operations will be defined inside the class, because operations are definitely what responsibilities those classes are being held of. And also review the entire process. So repeat until 1 to 5 until you are satisfied. And at this point also you should think of what design patterns you want to add. So as I mentioned before, that design patterns are good examples of how association and generalization could be used. So at this point you should find any suitable design patterns that suits your associations and design and generalization plan. In this way it will be easier to implement and modify the system or the model, and also the interfaces, which interfaces you can use in your system, like if you can generalize your class in terms of interfaces. And finally, when you have associations, attributes, generalizations, operations, and if you can find in design patterns, basically you should iterate step 1 to step 6 to improve the overall design or overall modeling. So there are some related online materials. The most interesting one is object-oriented-tips.org. So ootips.org. You can get many materials on UML and designing on this website. It's also a very rich website with lots of examples and use cases, where you can learn about modeling and how to use design pattern when modeling. And then you have UML, OCL, and other standards that I also used in this lecture. And I think that's it's time to finish the lecture. And if you have any question, I can answer them. I think I got a couple of questions. One from Muyad in the Slack, that does that black circle mean anything in the example of OCL? So which black circle she was talking about, or he?
I think it's the generalization.
Okay, I think in the OCL. So these black circles. So these are, I think she was talking about these black circles in OCL. So these are simply aggregation that is represented in Papyrus, and it's a representation of Papyrus modeling of aggregation. So which one you were talking about? And then there was another question: can Papyrus be used to generate code automatically and also generate the code for the constraint? And also, does it update the diagrams according to the code? Yes, you can also write code. Yeah, so instead of writing the constraint within the model, you can also write constraint as a code. So for example, if I go for here, new, so if you, so you can give a name, and then it will create a OCL environment where you can define any constraint. And for example, you remember the context command or context keyword. So for each OCL you have a context. This applies to a relation or class or object. So you define the context first, so which class or which relations or which method this applies to, this constraint, and then you write your OCL constraint here. So for each constraint you should have defined the context first and then the OCL constraint, like here. So if you have if you want to add a new OCL constraint here, just type the context. Let's say our context was person, and then you write your OCL constraint here instead of writing here. So it will be basically self and then dot whatever you want. self. Yeah, I think that was her question. And also, does Papyrus can be used to generate code automatically? No, it cannot be used. And also, does it update the? So she meant I generate an update with Java code. No, it cannot be. It can be only linked with the UML model, not presently with the Java code. And it cannot be used directly to generate the code for the constraint. You write it by yourself. But once you write the code, OCL code, it will automatically reflect with the model, and if you change the model, it will be automatically checked with the OCL constraint, and vice versa. That also I mentioned before. So do you have any question from here? So anyone from the Slack? So I will in the assignment there will be a simple very simple, fairly simple task on OCL, and so that you can introduce yourself to the OCL thing. And of course there will be something about UML modeling as well. So in the next slide, next lecture, we will focus on another tool that is also Eclipse based, but that it also has its own installer, but we will use Eclipse platform, and it will be about modeling security requirements. And thank you for coming and joining the lecture. So anything else from your side? No? Okay, thank you then.